All right, before we get into an actual question on exponential models, let's review what they look like. So if I have exponential growth, then the equation looks like this: a sub 0 e to the kt, where a sub 0 is your initial value and k is the growth rate. And when you graph these, I mean, a lot of people know about exponential growth because of COVID, or even any kind of disease, like you go to a daycare and one kid gets the flu and everybody gets it. It just rises exponentially very quickly. So the graph looks like this. Then if we have exponential decay, the equation looks a lot the same, except my rate now is negative. And so this is my decay rate. This is still my initial value. And on both of these, t represents time. So whatever the time you're looking at. And then if I want to look at the graph of this one, this would be decay. All right, so it's good to at least know what these graphs look like when you start to work these problems. So here I'm given a problem, says the half-life of radium-226 is 1590 years. So that's probably important. Half-life, so 1/2 or 0.5 of something. If a sample contains 200 milligrams, how many milligrams will remain after 1,000 years? So if I just start with this, my e to the kt, well, I know that half-life is half of what the amount that is there. And then this says at 1590 years. So what I'm going to end up doing is solving this for k. The a's cancel, because if you divide both sides by that amount, then we have e to the 1590k. And if you remember, we did this where we solve for exponential with logs. We do ln because it's base e. We ln both sides, e to the 1590k. And we get ln of 0.5. Remember, the ln and the e's cancel each other, so we get 1590k, and therefore our k is this ln of 0.5 over 1590. And we're going to use this value now. So to find the amount, it says how many milligrams. So to find the amount when there's 200 present, then e to the k, which is this value right here. So ln of 0.5 over 1590, and then times t, and it says at 1,000 years. Just be very careful, all of this is in the exponent. And if you throw all this in your calculator, you should get something like 129.3311 milligrams.